Okay, so we've got a question here. Telling us that the demand for good X, is given by this demand function here. We have QDX, which represents the quantity demanded for good X. And of this 6,000 minus half PX. PX represents the price of good X minus PY. PY is the price of good Y plus 9PZ. PZ is the price of good Z, and then half 1 over 10 M. M represents the average income of the individuals. So, as I said, in this demand function, there are one, two, three, four factors that affect the quantity demanded for good X. Okay, four factors. Okay, quantity demanded. This is the dependent variable. Okay, it's dependent on the price of good X, the price of good Y, the price of good Z, and the average income. So we can be able to tell this relationship between the quantity demanded and each of these independent variables, because the prices of these goods and the average income, these are the independent variables. Okay. So I was asking this minus sign in front of px, half px. What type of relationship is it showing between quantity demanded and the price of good X? What is the negative sign implying? Madam Linda? This minus sign in front of negative half px. It indicates a negative relationship between the price of good X and the quantity, which is telling us if the price of good X goes up, quantity demanded for good X is going to go down because of this minus sign. Because of this minus sign. Yes, there's a negative relationship. Basically, the law of demand. Remember the law of demand? Inverse relationship between price and quantity demanded. Ceteris paribus. Mhm. Then, if you look at PY also, there is a minus sign here. So it's also telling us if the price of good Y goes up, quantity demanded for good X is going to go down. If the price of good Y goes up, quantity demanded for good X is going to go down. Yes. Then here, as you can see, for PZ, it's a positive relationship. So it's what's telling us that if the price of good Z goes up, quantity demanded of good X is also going to go up. Quantity demanded of good X will go up. And then here, for M, there's a plus sign also, meaning if income goes up, quantity demanded of good X is also going to go up. So, question reads, research shows that prices of related goods are given by PY $6,500, PZ $100, while the average income of individuals consuming this product is M equals $70,000. A. Indicate whether goods Y and Z are substitutes or complements for good X. So, what is a substitute good and what's a complementary good? From your understanding? Yes, it's a good that you can replace with another good, right? Yes. Your volume is low, a bit lower. It's increasing. Yes, yes, like bread and butter. Butter is a complementary good. Yes, the good which is used with another good by itself, it's of no use. So these signs will be able to tell us which ones are substitute or complementary. So let's look at good Y. If the price of good Y goes up, it means the quantity demanded of good X goes down. Does this sound like a complementary or a substitute good? The price of good Y goes up and quantity demanded for good X goes down. Which one do you think it is? Complementary or substitute? No, not a substitute. Complementary. Okay, complementary. Let's say good, like the example you gave, um, bread and butter. Okay, if the price of bread goes up, people buy less bread, and so it's complementary, right? Yeah. So whenever you, yes. Even you can look at it the other way around. If the price of butter goes up, since people usually eat it with bread, they'll be reluctant to buy bread also. And so they'll buy less bread. Okay. So when it's a negative sign, they are complementary. So Y is a complementary of good X because we've got a negative sign here. Then Z, if the price of Z goes up, people stop buying with Z and then they start buying good X, meaning the quantity demanded of good X goes up. So they substituted good Z because the price has gone up with good X. That's why the quantity demanded has gone up. So positive sign is substitutes. So good Z is a substitute. Negative sign complementary. So good Y is a complementary. Excuse me. Complementary. So good Y complementary. Good Z substitute. Mhm. Negative complementary. Okay, then part B, is X an inferior or a normal good? So, what is an inferior good? What is a normal good? An inferior good is a good where when your income goes up, you buy less of it. Okay. Then a normal good, when your income goes up, you buy more of it. So here in this example, in this question here, we've seen there's a positive sign. So if our income increases, quantity demanded of good X also increases. So that implies that X is a normal good, yes. Okay. So now with this type of questions, because part D says how many units of X will be purchased when PX equals 5,230. So the first thing that you need to do with this type of equations, have you seen here they've given us values of PY, PZ, and M? Yes, these values we have to substitute it into this demand function so that we simplify it. Okay. Once they're substituted in the demand function will be simplified and we'll be able to tabulate it. So let's do it. Mm, So demand function equals 6,000 minus half px, because we haven't got a value of px before part D. Okay. Minus py is 6,500 plus 9, pz is 100 plus 1 over 10, then m is 70,000. Oh, Madam Elena, you're back. We are still doing this question here, the one which we started earlier on. Um, we're looking at this. We're on part D. So this video has been recorded, so you'll be able to watch it. Okay. So just hang in there and see what's happening. Right now, what we're doing here is these values they've given us in the question, PY, PZ, and M. We are just substituting them into our demand function. That's what's happening here. We're just substituting the values given to us in the question into our demand function. Okay, so you haven't really missed a lot. Okay, so it says 6,000 minus half px minus 6,500. 9 times 100 plus 900 plus 1/10 of 70,000 is 7,000. Let me just get bundles since my bundles are going down. Okay. Can you still get me? Can you still get me? Okay. My bundle's almost finished, so I just had to get new bundles. So let's do this. So 6,000 minus 6,500, that's negative 500. Negative 500 plus 900, that's positive 400. 400 plus 7,000, 7,400. So our demand function simplifies to half px plus 6,000 minus 6,500 negative 500. Negative 500 plus 900 positive 400. 400 plus 7,000 7,400. So we can rearrange this demand equation to 7,400 minus half px. Okay. So usually these type of questions, this is what will happen. Okay, they'll give you information about the other variables. You just have to put the values so that you get a simple demand function like this. Okay, these are the simple demand functions here. So 7,400 minus half px. Then in the question they're asking us what is how many units of x will be purchased when px is 5,230. So we substitute 5,230. Um, you substitute 5,230 into the demand function. So this is 7,400 minus half. Then substitute with 5,230. It's in the question. How many units of good X will be purchased when PX equals 5,230? So what is half of 5,230? Um, what is half of 5,230? 2, 615. Okay, 7,400 minus 2,615. 4,795 units. 85. So that's the quantity demanded for good eggs. Mm-hmm. Yes. You only use it at that stage because before you reach part C, yeah, before you reach part C, you have to substitute these values which I've put in red. You're supposed to substitute them into the demand function. Uh-huh. or how you know. Eventually, you reach the part where to tell you, okay, how many units of X will be purchased. So when you've reached that part, you would have to know that, oh, my demand function has to have been simplified by this part. As I said, with these questions, the format is standard. When you just moment you just see these values like this are given to you, just know you have to substitute. You have to substitute first. Once you've substituted, then you reach a part of the question where to tell you, like here it says, how many units of X will be purchased when PX equals 5,230? So the substitution can occur at any point before part C. Okay, any point before part C. Sorry, I can't get you. The last part of the question. Yes, yes, we're going to part D. Yes. Oh, yes, because of this. Have you seen this plus sign in front of this M? M represents income. So this, yes, so this plus sign, it is implying is that when your income increases, you buy more of good X. So your quantity demanded for good X also increases. So that implies a no more good. A negative then should be an inferior good, meaning, yeah, if your income increases and then you buy less of that good, that's inferior. Yes. Then for PY and PZ, since it's a negative sign for PY, it's telling us if the price of good Y goes up, quantity demanded for good Z will go down. So this implies PY is a good Y is a complementary good. Okay. If the price of this complementary good goes up, it means people don't are not buying good X. Okay, so quantity demanded for good X is going to go down. Okay, since good X and good Y are used together. Complementary goods are used together. Bread and butter, tea and sugar, phone and a screensaver. So if the price of good Y goes up, it means people buy less of good Y. And since they're buying less of good Y, and it's being used with good X. So since they're buying less good Y, they'll buy less of good X, and eventually quantity demanded of good X will go down. So that's why we said PY is complementary. Yes, then for PZ, it's a substitute good. If the price of good Z goes up, it means it becomes expensive, so customers buy more of good X. They substitute good Z with good X. Okay, so part D, determine the demand function, which we've already done. The demand function is this: Q equals 7,400 minus half px. So the one the demand function and the inverse demand function. The inverse demand function is where we make px the subject of the formula. Okay, the normal demand function, Q is the subject of the formula. Okay, but in an inverse demand function, Px will be the subject of the formula. Okay, so, we have to make, An inverse demand function, Px is the subject of the formula. Price is the subject of the formula for an inverse demand function. So here we can make Px the subject of the formula. Many ways to do it. If you want, first we can convert this into a fraction, into a decimal. So 7,400 minus 0.5 px. And then you have q here. So you want px by itself. Since you're making px the subject of the formula, you want it by itself. Okay, colleagues? So the way we can isolate px by itself is if we take it over the equal sign, and then also q, we'll take it also over the equal sign, okay? So that px becomes positive. So when you take negative 0.5 px over the equal sign, it becomes 0.5 px. And here we have 7,400 minus q. Okay, because this positive q, we took it over the sign. Then we divide both sides by 0.5. So it becomes px equals, now if you want, you can leave it as like this, 7,400 minus q over 0.5, or you can put it like this, 7,400 over 0.5 minus q over 0.5, and we can simplify it further. What is 7,400 divided by 0.5? Should be 14,800. Then here it's like you have a 1q. So what is 1 divided by 0.5? That is 2. Yes. Or 14,800 minus 2q. So you can either leave your inverse demand function like this, 7,400 minus q over 0.5, or you can simplify it further like this. Even like this as a fraction here, you can still leave it like this, but it's better you leave it like this because you'll be graphing the demand curve. So it's better you're dealing with numbers, whole numbers. Any questions? Mm-hmm. Yes, where are you not? Mm-hmm. Mm-hmm. No, I never said you use profit. I said the inverse demand function, you make price the subject of the formula. That's all. Just make price the subject of the formula. Any other questions? I believe we know how to graph. It says graph the demand curve for good X. So graphing also, and you see from the demand function, you can tell what can I say what range of units to use. Okay, so since it's 14,800, so we'll put them in units of 2,000. So good X here 0, 2,000, 4,000. Let's see, in twos, 2, 4, 6, 8, till reach 14. Okay, 2, 2, 4, 6,000 here. Then on the Y column here, you also put 2,000, 4,000, 6,000, 8,000, 10,000, 12,000, and you have 14,000. Price on the Y-axis, quantity on the X-axis. So it's just a matter of putting values of Q. You say if Q equals 0, you substitute it into this demand function here. 14,800 minus 2 times 0. 2 times 0 is 0. So 14,800 minus 0, that is 14,800. So 14,800, it's above 14,000, so you can plot it here. When Q is 0, the price is 14,800. And there's no formula. Yeah, the formula you're using is the inverse demand function. So if Q equals 2,000, yes, yes, the 0, you replace it with Q. After I get, so when you replace it with Q, that's how we got 14,800 as P. Then next, you say when Q equals 2,000, again, you substitute this back into this inverse demand function. 2,000 times 2, that is 4,000. 14,800 minus 4,000, that's 10,800. So here we have 2,000, 10,800, we estimate it somewhere here. So your next point is here. 10,800. Then you go to the next one. When Q equals 4,000, substitute Q with 4,000. 2 times 4,000, that is 8,000. 14,800 minus 8,000, that is 6,800. So here on 4,000, 6,800 is somewhere here. So with 4,000 there, okay. And the process goes on, and you eventually get a downward sloping line like this, showing the law of demand basically.